All right. Hello. Hope this finds you well. So, the essential question: how can I find the probability of a simple event and its opposite event? And then, how do I change that probability into a percent? So, pretty simple, straightforward lesson. I'm going to move through it quickly. Probability, the chance of favorable outcomes divided by or in proportion to total outcomes. You have a six-sided dice or number cube, your book will call it. What's the probability of getting evens? So think to yourself, oh, evens on a dice would be 2, 4, or 6. So it looks like I have 3 chances of rolling an even out of 6 sides in all. So that's 1/2, and we already have done this before, changing to a percent. Oh, that's 0.5 or 50%. Okay, one more time. There were 3 evens, so you have 3 out of 6 sides in all, and then changing to a percent should be reviewed by now, guys. Probability of rolling less than a 5, and guys, I'll try to move this if that helps. Maybe that helps on this one. So probability of less than a 5. So hear it as, oh, I could roll a 1, 2, 3, or 4 on a number cube. Those 4 are all less than 5. It doesn't say include 5. So you'd say, oh, that's 4 chances out of 6. And when I divide that, I get 0.666. Move the decimal 2 places to the left, and you'd get about 67% chance. Okay. Um, Sometimes if it were IXL, you could have just reduced that 4/6, and IXL might also say just reduce it to 2/3. Okay. Here we go. Next one. Whoops, got to move my little picture again. There we go. There are 35 students. 22 were in swimming and 13 were in track. If you were to draw a name, what's the probability of drawing a name of someone in swimming? So you'll see probability written like this: probability someone in swimming, and it'll be in parentheses like that. And you would just make a ratio. We've done that part before. Here we go. 22 out of 35. And then I did ahead of time change that to a percent, and I got 0.628. That 8 would round it up to 63% chance. So depending if they want you just to leave it 22 chances out of 35, you could just leave it like this. Or if they ask you to change it to a percent, change it to 63%. Complementary, we've done this. Complementary is like opposite or out of 100%. So then you would say, how many are not in swimming? So the probability of somebody's name being drawn, here we only have 2 choices. So we would say the probability of them not being in swimming are 13 out of 35. And then if you were changing it to a percent, I would truly just do 100, take away 63 is 37. So that complementary means together, the two should equal 100%. So that would be 30% or 37%. Okay, here we go. In a deck of cards where you have 13 hearts, 13 spades, 13 diamonds, 13 clubs, what's the probability of drawing a heart? We got this, right? There's 13 hearts, and a card deck is 52 in all. And then if you reduce that, that's 1 out of 4. Every 1 out of 4 cards is a heart. And then if you change that to percent, we've done that, 0.25 or 25%. Then easy, probability is not a heart. I would say, oh, 3 out of 4 because 4 out of 4 is the whole deck. So if the whole deck take away 1/4 of the heart, 3/4 are not a heart. And then if you change that to a percent, 75%. A deck of cards numbered 1 through 20. What's the probability of drawing a multiple of 4? We've done this, we've done multiples. You just say 4, 8, 12, 16, 20. So how many is that? 1, 2, 3, 4, 5. 5 out of the 20 are a multiple of 4. Then reduce. 5 divided by 5 is 1. 20 divided by 5 is 4. Looks like another 25%. Oh, prime numbers. This is a great review. Probability that one of the cards you draw is a prime number. Go ahead and take out that hundreds chart. And I made a list. Out of 20, the 2 is prime, not the number 1. Don't put the number 1. The 3 is prime, not the 4, the 5, not the 6, but yes, the 7, not the 8, not the 9, not the 10, 11, not the 12, 13, not the 14, 15, 16, but 17 is, not the 18, but the 19. So how many primes was that? 1, 2, 3, 4, 5, 6, 7, 8. 8 prime numbers out of the first 20 digits. And to change that to a percent, oh, I didn't do that ahead. Uh-oh, calculator. 8 divided by 20, oh, 40%. 40%, that's interesting to me. 40% of the first 20 numbers are prime. All right, I think that was my last slide. I was trying to make it short. Keep in mind that if there were more, then let's just do a quick one. Let's just do a super fast one. Pretend we had marbles. If we had like 4 blue, 5 green, and let's say 6 yellow. And so hopefully you're listening and not just watching. That's marbles we're talking about. If it said the probability of green, then you would just say, oh, I have 5 green out of, 15 in all. So we'd say 1/3 or 34% or 33%, it'd be okay, are green. So if you have more than one category, you'd still put the total in the denominator and how many you're looking for in the numerator. Okay, tried to keep it a short video, but hopefully probability makes sense. Let me know if it does not. If you're confused by anything, please let me know. Bye, guys.